Hello everyone, good morning. Dear authors and invited guests, I welcome you all to the technical session 5E. Myself Siddesh Mogal and this session will be moderated by me. On behalf of GR Knowledge Research Foundation and GR Scholars LLP, it is my great pleasure to welcome you to the 9th International Conference on Information and Communication Technology for Intelligent System ICTIS 2025 Bangkok, Thailand. The ninth edition of the conference is being organized in a hybrid mode. The physical event was held yesterday in Bangkok, Thailand, and the virtual event is being held through Zoom today and tomorrow, that is 5th and 6th April 2025. I hope you will enjoy the knowledgeable and interactive session through the day. This session, we have 10 presentations. Each presentation will be for 10 minutes and 2 minutes for the question and answers. On 9 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before the session starts, I would like to introduce you all our chair for this session. Our first chair for the session is Professor John Helen Jaspersi Ortega. Professor John Helen Jaspersi Ortega is a professor at FEU Institute of Technology, Philippines. With extensive experience in the information technology and service industry, skilled in blogging, creative writing, technical writing, and project management. He brings a multidisciplinary approach to education. His expertise spans information system, business informatics, programming language, and software engineering, contributing to the both academic and industry advancements. Sir, would you like to give any opening remarks to the participants?
Hello everyone. For today, I'm just hoping that everyone will have a very productive and fruitful morning, and we hope we learn a lot, from this session. That is all. Thank you.
Thank you so much, sir. So also our second chair for the session is Dr. Navneet Sharma. Dr. Navneet Sharma is an associate professor in the Department of Computer Science and IT at IIS University Jaipur, with 17 years of teaching experience at both UG and PG levels. He is actively associated with various research associations, universities, and consulting services. His research focuses on e-commerce, cloud computing, and network security with over 25 research papers published in reputed international journals. Sir, would you like to give any opening remarks to the participants?
Sure. Namaskar, everyone. All the best from my side for a wonderful session. And all the presentees I welcome in this session on the behalf of GR Foundation. Thank you.
Thank you, sir. So now I would like to start with papers. The first presentation is presented by Ayush Kumar, and he is presenting a novel hybrid model that generates password. Ayush, you can start your session.
So let's start with the introductions. My name is Ayush Kumar, a student of PES University and one of the co-authors of of our research, a novel hybrid model that generates password. So before I go over all research details, this is the outline of today's presentation. So let's start with password security. Why passwords are such a major breakthrough? As we all know, like passwords are really iconic and they serve as a major way of user authentication to widespread audience. But due to its primitive method, it often falls into data breaches and poses a security risks as many of the users prioritize memorability of the password instead of its security, uh, filling it with common patterns or easy to guess patterns. So these patterns are very prone to be discovered by an attacker, thus breaching data or just leaking data in general. So our research explores the potential of probabilistic context-free grammar and Markov model together to generate passwords. By doing so, our aim is to empower cybersecurity analysts, forensic analysts, and research with a potent toolset for assessing security within digital ecosystems. So let's start with the implementation details. So our approach involves the sequential run of Markov model and probabilistic context-free grammar model for password generation. These passwords generated by these specific models will be aggregated in a common list. This combined list will be then tested against a separate testing data set to evaluate the effectiveness of our model. The objective is clear that we want to improve the success rate over the existing models while like having the strength of both the models while generating realistic password patterns. This is a model architecture. As you can see, we control everything through a controller file to invoke both the models. Both of the models are trained on the same training data set, which is the ROCU data set. ROCU data set is the biggest repository of leaked passwords, which happened in 2009, and it is extensively used for password generation and related research. After both the models are ran, a final combined guesses are created, which is matched against a test set, and an end result is generated, which is in form of success rate. I'll go over the evaluation policy in just a bit and the specifics of how both the models are actually working. So let's start with the PCFG model. PCFG model is a template-based model. That means when it reads the training data sets itself, for example, one of the password in training data set is JSON@123. It converts it into a template of letter, special character, and digit. So as you can see, JSON is a 5-letter word. We have one special character @ and 123 as digits. Henceforth, we get a template L5S1D3. Using this template, pre-terminals are created. What are pre-terminals? Pre-terminals are just filling the template with special character and digits according to the external dictionary which is provided to the PCFG model. These special character and digits are actually based on probability of occurrence. The letters are further filled using an external dictionary, henceforth creating the final guess. So for example, we have JSON@123. The pre-terminal created would be JSON@111, 123, 134, and so on. That L5 will further be filled by an external dictionary to PCFG. For example, it can be filled with mango@111 or any other 5-letter word. One thing to note is that after training, the PCFG model does not contain any information of the existing training data set. For example, after reading this JSON@123, the PCFG model won't have any information that JSON@123 134 exists as a word in our training data set. It only remembers the template and the probability of occurrence of template. So hope that is clear to everyone. Let's move on with the Markov model. So Markov model is a generational model which is based on n-gram probability table. So what is a n-gram probability table? When the Markov model is trained on a training data set, it creates an n-gram table. N-gram table represents how much probability is of the next letter being added to a word. For example, let's take my name as an example. Ayush is a common word. Uh, so how after reading the training data set, a Markov model will learn that A followed by A is, for example, 7% of the time, while A followed by B is 2% of the time. So it will generate passwords based on likelihood of next character occurring. So it will choose A just because it has higher chance of occurrence. So for uh, mine, uh, the first guesses will be A, then it will move on with the lower probability, A, B, A, C, respectively, based on probability of next letter occurrence. That is how n-gram is decided and guesses are made. So, Markov model is just simple. Moving on. This is our evaluation framework. Our main objective is success rate, in most cases called hit rate, which is number of cracked passwords divided by number of passwords in the test set multiplied by 100. Uh, our objective is to compare the hit rate at different password level generation, for example, 1 million, 10 million, and 100 million passwords, and so on, using traditional Markov model, traditional PCFG model, and the hybrid model, which we are using. So these are the results of our testing over different data set. Note that both of the models are trained on ROCU dataset. MySpace dataset is another leaked dataset of 2011, which contains almost 37,430 words. After our testing, as you can see, our hybrid model performs better than the traditional models, which is the original PCFG model and Markov model, with quite a significant margin. Uh, I would stress more on the fact that Markov model has a weakness of plateauing after a while PCFG model only has high hit rate in the initial run of the model. Moving on. This is Hotmail dataset ran on the three models which we are using. The test set size is 8,000 and this was 2013 leaked dataset. As you can see, our hybrid model still performs better than the original Markov and PCFG model. The third instance is the ROCU dataset itself. ROCU dataset is the biggest repository of leaked passwords. It contains 14 million passwords. We trained a model on random 2 to 3 million password and we used 10 million as a test set. After testing, the highest hit rate achievable by a model is 43.3%, while the other model barely make it to 36.2%, while PCFG only having 18.1% of success rate. So final words by me and conclusion. So as signified by the results provided, our model has successfully combined PCFG and Markov model to produce better success rate than individual models itself. This is because the strength and the approaches used by both of the models are quite unique, thus increasing the accuracy and reliability of the prediction. One of the challenges, though, which we are still working with, is it is a considerably high RAM utilization model. Thus, we are further researching on optimizing on lower end machines. Uh, these are our references. Thank you. Any questions?
Yes, I have one question.
Yeah,
Are you
sure.
getting my voice?
Yeah.
Yes. On which parameters you have compared all these models?
I'm sorry.
On which parameter you have compared all these models for the enhancement?
We have tested it on success rate. Success rate is basically how many within how many we have a limit of guesses. For example, 1 million guesses, 10 million guesses, and 20 million guesses. We have tested it upon those guesses against how many passwords there are in the test set. For example, as I showed in the evaluation policy, its number of cracked passwords, which is cracked by the individual models and the hybrid model, divided by number of total passwords. So it's just a simple percentage. Hope that served as a fine answer.
Okay, thank you.
All right.
Any more
And I also
questions?
have, yeah, I have one question. No? After conducting this study, what limitation no, did you encounter on relying on auto-generated password, if there is any?
Assuming you're asking the question that what are the limitation
Yeah,
in
yeah.
auto-generated passwords,
Yeah,
right?
relying on auto-generated password. Yeah, correct.
First limitation and the biggest one is that the initial guesses of PCFG model are not that reliable just because, I'm sorry, Markov model are not that reliable because it does not have a sense of let syntax or the word making sense. So some of the words initially generated are just jargon. So Markov model picks up its pace after a while. uh, I would also like to address one security concern that like this research can be used as uh, since we are dealing with passwords and password generation, actual password generation deals with hashing and salting, which I'm not going to get into. But yeah, the initial password generated by both of the models are very weak passwords and thus does not provide any value to the success rate itself. After running the model for quite a while, you will start seeing results. You have to run the model sequentially and you cannot use Markov as the external data sheet for PCFG itself due to the same reasons. Hope that served as a good answer.
All right, perfect. Thank you.
Thank you.
So our next presentation is presented by Saumin Halder. He's presenting paper title Cyclone Damage Detection Dataset for Disaster Impact Assessment. Saumin,
Yeah,
you
hi.
can start your presentation.
Yeah,
Yeah.
sure. I'm sharing my screen.
Yeah.
Thank you. Thank you for the confirmation. Hi. Good morning. Good afternoon. Myself, Shoumen Haldar. I am presenting cyclone damage detection dataset for the disaster impact assessment. A quick review of my other co-author, Bidit Sadhukan, Debojyoti Maiti, Shubhmay Vaduri, Rahul Bhattacharya, and Shagnik Datto. All we belongs to the Einstein Young India. All we worked as a data scientist here, and Syed Umar is our academic guide and help to as an academic head. Now move to the today's thing. I will try to cover. Uh, uh, I will introduce the topic first with the then I will introduce the data set along with few the EDA or the exploratory data analytics, and then the modeling with the augmentation thing, and I will show few result along with I will conclude my words with the challenges and the future scope. Natural disaster like earthquake, tsunami, or cyclone is really threat for the humanity. Nowadays, we have able to develop few prediction tools for to predict such event, but for the rescue or the to help the needy people, we require some more tools or we can support them. Here we introduce a data set with a baseline result for the post-cyclone event. Yeah, that we believe that it will help the government and the ML and the scientific community like ML and CV people for the further research. We believe it reduce the human intervention and human effort to detect the damaged area or the rescue the needy people. Our data set is a satellite image. The data region is Petro Regio Island that is located near about the Caribbean Ocean, and data captured by the Maxar GOI satellite on the 10th September 2021 when the cyclone Mariana hit the island. The left hand side of the left hand side image, it shows the captured satellite image in the 3 spectral in RGB spectral. Dataset contain both pre and post event data, which is used for the annotation purpose, and for the modeling purpose we have used the post event data. The original image is a single large image that is formatted GOT format, which is not at all comfortable for the machine learning, even not an human readable format. So the pre-processing plays a huge role here. In the pre-processing, we actually process the a large satellite image into an machine readable format. In this process, we have divided image into smaller grids, and then further processing respect to the machine learning, and final data is saved in a JPG format. So GOT to TIFF to JPG format. The details of the pre-processing is patented by us. You can find this in the Government of India copyright registry. Here the details is given. Now move forward. The pre-event here you can observe two images that they are in images. One is pre-event and another is in the post-event, and we have annotated the images in the using the rectangular box. Here the annotation comes into the play. For the supervised machine learning algorithm, we need the labels, and here the annotation comes have a huge role, but the dataset is not at all annotated, and no information related the box or the annotation or the label, whatever you can say, that is not there at all. So we have spent plenty of time to annotated the image. The the rectangular box at the this one I don't know my cursor is visible or not. This one, the rectangular red color box, is the annotated and a damaged image, you can say. Now further now move forward for the EDA thing. Our total data we have total 10,000 and 700 approx images, where we have observed that around 6,838 image, almost 68% image having building, and other rest 36% don't have building, either having clouds or the images of the forest or the sea. Now the classification as we classified data into 4 subclasses, that damaged residential, undamaged residential, and damaged commercial, and undamaged commercial. You can, from the pie chart you can observe that the damage sorry, the undamaged image is in highly skewed. Now further, if we divided the image out of 6,838 almost images, we annotated almost 16,000 building over 200 images. Sorry, 2,000 images. Over there we have observed that 10,000 images are there residential building, and 6,000 are the commercial building. Approximately 20% are the commercial damaged, and 34% are the residential damaged. The augmentation, as we have a the thing I like to highlight, as I mentioned that we have manually annotated the images, so it is difficult to annotate the whole image. So we have taken very small subset of the image. For this study we have taken around 1,000 images, and as I show in the pie chart, data is skewed. So for two purpose, for the model training purpose, we need to increase the data. Another reason is to reduce the skewness. We need to do the augmentation thing. We use some traditional augmentation algorithm like rotation, flipping, shifting, and increase or decrease the brightness is to increase the number of sample size. And finally we splitted the data into train, test, and validation in 70, 20, and 10 ratio. And now the modeling, we have used 4 state-of-the-art object detection algorithm, ELO, V8, and V9. ELO is the most simplest and the single pass algorithm that produce you an very decent result, where detectron 2 is a kind of the traditional machine learning object detection algorithm, where the use the ResNet it produce the object detection. And the detection transformer again is a state of the art algorithm based on the transformer logic. It do the object detection. Yeah, now comes into the result. I will go back to those slide. Before that, here the result produced by the machine. The post event annotated image. The left hand side is the ground truth, and the right hand side image are the predicted. We how the model performance, we will judge by the few matrices. Yes, but here the first cut result you can say. Now the matrices here, few the basic concept in IOU is an intersection over union. This is a metric that
Soman, sorry to interrupt. Your 9 minutes are over, so kindly wrap up your session.
Yeah, sure. This is the IOU. This is an IOU, and another few are that box precision recall. These all are used to judge the model, and MAP that is used by the IOU. IOU on a certain threshold, you take the you get the precision, and again MAP 0.5 to 95 to 0.95, that is again evaluate the precision over a certain ratio. Here the graphical representation of the matrices, and here is the tabular representation of the result, yellow V8, yellow V9, and detectron 2 and the DRT detection transformer. Now the challenges: for the less amount of data, model not able to produce very good amount of result. Again, we have produced only the baseline results. So So this is further can be modified, and as the data have a CT data, so it is very difficult to annotate, and various issue like shadow and the cloud have makes the things more difficult. For conclusion, we conclusion of the further work, we can do extend the work for the large amount of data set. For the we can produce smart report to help the government more, and we can optimize the pipeline and the model, all to get more better efficient and result and the accuracy and in terms of time and the performance. Thank you. You can ask me the question.
So our next presentation is presented by Anita Kumari Sivanthu. She'll be presenting paper title Design and Development of the Autonomous Robot for Firefighting Application. Anita, are you here?
Yes, sir.
Okay. You can start with your presentation.
Thank you. Hope my presentation is visible.
Yeah, it is visible.
So, very good morning to all the scholars here. So, the paper that I am going to present today is Design and Development of an Autonomous Robot for Firefighting Applications. So firefighting robots, it is not fully automated. The presently with the firefighting robots that has been in field for extinguishing fire, it is not fully automated. So here we have developed a prototype model of a fully autonomous firefighting robot, and this uses some modular, with the help of some modular components and sensors. We are able to achieve this, and we have automated this by using implementing the Arduino Uno program using the microcontroller. So this is the block diagram for our prototype model. So the heart of the model is the Arduino Uno, which carries the program that for automation. So we have used fire sensors in all the directions. That is, we have used fire sensors to just sense the hazard in all directions, and also we have used an ultrasonic sensor to detect the obstacles. If at all there is any obstacle in the pathway of the robot, then that will be detected, and it will just try to overcome those obstacles in order to reach the fire location. And we have used servo motors for the positioning the water splasher. Now that is a nozzle which will just splash the water whenever to extinguish the fire. And we also have the motors, DC motors, which is used to drive the wheels of the robot. And we have just the driver module. It is used to drive the motors. This is the basic structure of our model. And this is the model that we have just developed. So as you see in the figure, this is the front view, side view, and the back view. So we have just made the 3D printed prototype model. So this as you see in here, this is the chassis, and we have the headlights. So this is the upper body, and here as you see you have the water spray nozzle, so which will just create an infinity pattern. So it will just move as an infinity pattern in order to extinguish the fire. So this is a we have two revolute joints in this link. So it can have this rotation which yield the infinity pattern. And we have the sensors, that is, we have placed the ultrasonic and flame sensors in all the directions. We have placed the flame sensor so that it can detect the flame in any directions. And we have used belt drive system, and this belt drive system, it will it can just move in any uneven terrains also. So even this robot can just move in any uneven terrains also. So we have used a track belt drive system for movement. Um, Yes, we have also provided the charging ports for charging the battery, and this is the structure of the prototype model that we have designed. And before just proceeding to the implementation part, we have just analyzed we have done a simulation analysis on how to just for programming, we just want to analyze the whether our robot is able to just overcome the obstacles. So as you see here, with the green, this is our robot, and the red point here, it refers to the obstacle. Sorry, it refers to the hazard, fire hazard. And here, in between the path, we have just placed many obstacles, like the red points, that is this points, or the obstacles. We have just analyzed. So as in the next picture, as you could see, the first obstacle that the robot has met, it has been overcome by the robot. So this is the initial position of the robot, and the obstacle has been overcome. In the next image, as you can see, this obstacle has been overcome. So likewise, it will just try to reach the, as you see, this is the point where it has reached the fire hazard. So it will try to reach the fire location by overcoming the obstacle. So this was possible as because we have obstacle to overcome the obstacles, we have ultrasonic sensors placed. So this is the algorithm that we have just coded in our controller, microcontroller. So first, the ultrasonic sensor, if at all there is any detects any object, then there will be, the motor will just will be just it will be turned to some angle. And in the same way, if at all any flame is detected, then it will just go to that, to move forward to that particular distance. uh, so the user, so here as you see, once it has reached that distance, it will stop there, and then it will just try to extinguish the fire by actuating the water spray. So this is the algorithm which we have just coded, and we have embedded in the controller. So in the implementation, as you see, we have just generated an artificial fire here, and the robot, it has detected the fire, and in the next image, as you see, it has started moving towards the fire. And in the third image, the motor pump is activated, and it is just trying to extinguish the fire. So these are the key factors in the while testing the hardware. So our prototype model, whatever we have developed, it was able to just detect the fire within the range of 60 to 80 centimeters itself, and this is approximately plus or minus 5% margin. And also we were able to detect obstacles with the help of the ultrasonic sensors. The obstacle detection was also successful, and we have the servo driven plotter spray, which was efficiently functioning for extinguishing the fire. And also, most importantly, the model was stable enough to, with a payload of up to 5 kgs, it was stable enough to just extinguish the fire. So to conclude, the by using the modular components like phase sensors and ultrasonic sensors, we are able to successfully fully automate the fire extinguishing system by using our robot. And as a future scope for improvement in the same model, we are plan to integrate the AI decision making process for better obstacle avoidance. And also, we have a plan to implement the wireless communication for remote control and monitoring. That is, the user who can just monitor the robot, and the information, live information, can be just got to the sent to the user. So this is what we have planned to incorporate in the same model as a future work. So these are some of the references. Thank you.
Yes, one question from my side.
Yes, sir, please.
Anita, how many sensors you have planned in a one piece of robot?
No, flame sensors, we have used four at the front side and the rear side. We have used flame sensors so that it can detect the flame in all the directions.
And What was the configuration of the sensors?
The distance it has, it can detect at least for 10 centimeters, it can just detect the fire.
Okay.
All right. And on one question from me, what was the biggest technical challenge you've personally faced while developing the robot, and how did you overcome them?
Yes, so integrating the sensors with the controller, and also the obstacle reduction, it was actually a big challenge for us. As because uh, uh, no, we require some ultrasonic sensors. It didn't. We support for the which the when the obstacles is placed for a very long distance, of course we cannot detect, but we had some challenges in integrating the sensors, especially to the track.
So up next we have Usman Dilao, and he is presenting the paper titled Design and Implementation of an IoT and AI-based smart cane for improving daily life of visually impaired people. Sir, you can start your presentation. Usman, sir?
Yes. Hello everyone.
Okay, sir. You can start your presentation. Yeah, your screen is visible.
Yes, yeah. Hello everyone. My name is Maisage. I'm here to present the design and implementing of the IoT and AR model, and AR model based into the smart can for the improvement in daily with life of visually and impaired people, presented by Usman Jallo and Hashim Alingdoy. Our presentation outline is a flowing, is a flow, is as a flow. Introduction, related work, contribution, evaluation and validation, and the conclusion, and the future work. In Senegal, around 165,000 people are blind, and over 6,000 are partially sighted, representing of major challenges in the term of accessibility and mobility. And many solutions with here, but the lack of the appropriated technology means that the people are dependent on assistance to get around limited their independency. It is in this context that our problem emerged, who is how can we design intelligence can based on IT and ER and IE to improvise the autonomy of blind people and in Senegal, taking into the account local constraint. And the goal of the project is to combine the IT and the AR model in the AR model for to obtain in order to obtain the network that to connect the user and the administrator and the teacher. Now they have a many person who working in this project, but however many of the limitations the the absence of the eye for obstacle recognizing the lack of the platform for monitoring user, the sometimes limit the detection range, and the lack of integration of the solution for visually impaired people who also suffer from the hearing patient. And our contribution is to offer solutions that combine obstacle detection, localization, and contextual recognition of surrounding object using AI. This approach is based on the existing architecture, but enhanced by the addition of the new functionality. The microcontroller with Arduino card and the Raspberry card with a hybrid network with and the component sensor IoT and on IE model. We have a architecture system. We have a hardware architecture system. When the obstacle is detected, see the camera by send the image in to the cloud for to analyze it, and the administrator can localize the user of the card with the platform, and a tutor can localize the user of the card, and we have a software architecture with a different layer, the physical layer, the communication layer, with the prototype, and the application layer. We have an algorithm of the algorithm of our system. If the CAN is on, the GPS mobile is on, and the ultrasound is on. In the GPS, update the localization and speed at set frequency. If a localization position if localized the position, the notification, they have a notification to the tutor on the one. If now she update the localization in speed, and we have iteration. If the obstacle is true, we have a active vibration, and the camera is on for the obstacle vision, the obstacle analysis via the pre-training AI model. If a good occurrence score on obstacle identification is yes, or alert the nature of the obstacle and send to the application. If the application if the CAN is on, is off, it is the end of the algorithm. We have a component with the sensor filtration with the module, the ESP, and the GPS. We have a Arduino card, but Arduino card and the Raspberry card. We have the camera and the buzzer with the vibration model. And this is a prototype of the smart card, our smart card, with a different compartment. We have used the software technology with the platform of Arduino, OpenStreetBoot for the localization. We have a MongoDB and Visual Code to deploy our platform. We have a label IMG, Google Colab for training our model. Python, we have using the Python, OpenServer, and the model YOLO model. And we have obtained the table of score. If we train in our model in the first two, we have a score of the score precision is 40%, and in the last test we have a score precision who is that is 18%. And there is a platform for to administrator, and the administrator can to add a new user, and we can, and he he can locate the user in the platform. And this is a test of the smart token front to the chair and the person who is in the person. This class is in our model training. And the conclusion of the word is efficiency, a system that connects user to the environment, relativity and durability, a satisfactory detector, identification and localization system, a profitability. They have the autonomy of its user. And the prospect are a cardiac monitoring system at a heart rate sensor, remote the control, guiding the user from on the place to another with a remote assistant, GPS model to integrate the GPS in the scan for to emerge the call. They are improving the AI model, increase the capacity of our data set and the class. Thank you for your attention.
Yeah, Navneet sir and John sir, do you have any remarks or any closing questions?
Yeah, I only have one question for Misa. I mean, for the study, how did you ensure the re- reliability and efficiency of that smart gains, connectivity, and data processing in different environments? Like, for example, if there are some obstacles or,
I don't understand.
uh,
Can
uh,
you
yeah,
repeat?
yeah, sure. How did you ensure the reliability and efficiency of the smart gains, connectivity, and data processing in different environments? Like, for example, when there's an obstacle or if there's a block, in the signal.
But we have testing our smart account in this environment in this context who is Senegal because when I in this Senegal we the world we have testing this kind we front to the world and and many obstacles. Some
All right, thank you.
Okay, which cloud model you have used in your experiment?
hmm? uh, Samuel, we have using yellow for the for training the model.
So your proposed model is for the public cloud or the private cloud?
We have using yellow velvet to train the model to train the model.
Okay, thank you.
Okay, thank you.
Thanks, sir. So up next, we have Satya S. She's presenting the paper titled Harnessing Quantum Machine Learning Techniques for Enhancing Crop Productivity. Satya ma'am, are you here?
Yes, sir, I'm here.
Okay. You can start your presentation, ma'am.
Okay, sir, thank you. A very good morning to everyone present here. It's my honor to present my paper in the 9th International Conference of Information and Communication Technology for Intelligent Systems. The title of my paper is Harnessing Quantum Machine Learning Techniques for Enhancing Crop Productivity. Author details, myself Satya, and my co-author is Madhumati. Here is the agenda. First, introduction, literature survey, problem definition, proposed work, methodology, result, and conclusion. Abstract. So quantum computing introduced a new methodology in the data processing by employing this quantum mechanics to improve computational efficiency. So quantum mechanics is a form where the computation is done at the atomic and subatomic scales. So this study explores the application of two algorithms. First one is Pegasus quantum support vector classifier, and another one is quantum neural network for agriculture data analysis, focusing on the crop classification and prediction. So the experimental evaluation reveals that these two algorithms, first one is Pegasus quantum support vector classifier, achieved an accuracy of 88%, whereas the quantum neural network attains the accuracy of 70%. So the use of quantum future encoding and circuit-based optimization contributes to this effectiveness. These results emphasize the promise of quantum algorithm in enhancing productivity, analytics, and provide more precise decision-making in the sector of agriculture. Introduction. So machine learning has surfaced a revolutionary tool in multiple sectors such as agriculture, healthcare, and finance. So with the extensive quantities of data produced in agriculture, including soil condition, weather patterns, and crop yields, ML techniques are increasingly being applied to optimize this agriculture practices. The application of ML agriculture spans a wide range of areas, including crop prediction, pest detection, precision farming, and soil management. As the complexity of the agriculture data increases, quantum computing has started to gain attention for its potential to handle such data, that is huge data, more efficiently, particularly through QML. So here's the literature survey. So the author in one proposed the use of variational quantum circuits for this agriculture, in the precision agriculture, for demonstrating the superior accuracy in crop production prediction. So this study highlighted the potential of QML in enhancing this agriculture. The author in two explore the use of quantum support vector mission and quantum neural network for improving this crop yield prediction. So by leveraging the data, the study demonstrated that QML models suppress classical techniques in terms of accuracy. So the author in the three integrated QC with classical networks to enhance the rice leaf disease classification. So the author also used QNN, which shows the high accuracy in improving the agriculture disease detection. The author in four investigated the role of quantum computing in smart agriculture, focusing on QML models. Next, the problem definition. The complexity of the agriculture data increases rapidly, and the need for more advanced computational models are in need of requirement in today's world. The problem centers around optimizing these agriculture practices through QML techniques. So there are various QML techniques. QML is nothing but quantum machine learning. So under this quantum machine learning, we have various algorithms like quantum support vector machine, variational quantum classifier, Pegasus quantum support vector classifier, quantum neural network, quantum convolutional neural network. So among them, I just chosen the two algorithms that for this work experiment. The motivation of these methods is their ability to handle this large data set more efficiently by leveraging this quantum superposition and entanglement. The superposition is that the qubit can be existed in both the states, that is 0 and 1 simultaneously. Entanglement is for the understanding the more complex relationship in the data set. Here is the proposed work. So this Pegasus quantum support vector classifier is an extension of classical support vector classifier. As the classical and quantum, there are two different things. So classical, we have support vector classifier. Similarly, in quantum, we have quantum support vector classifier and also Pegasus quantum support vector classifier. This Pegasus quantum support vector classifier leverages this quantum computing to enhance this classical classification performance. In this PQSVC, it utilizes the parameterized quantum circuits, which is a very important concept to map the input data into higher dimensional Hilbert space for this better class separability. Next one is quantum neural network. It is an extension of CNNs, integrating this quantum computing with the neural network architecture for better feature extraction and classification. Methodology and implementation. So the first step is that collecting of data. So the data contains various features such as soil parameters, weather conditions, and crop characteristics. Soil parameters is not the macro and micronutrients of the soil present in the soil, like values of P and K, that is phosphorus, nitrogen, potassium, and weather conditions like rainfall, humidity, and all those things. And finally, the characteristics, the soil color, and all those things, with the target variable as the type of crop that can be grown. So next step is that pre-processing. For every implementation or methodology, the pre-processing is one of the most important and first step. So whereas in pre-processing, will be using the futures are normalized using a min-max scaler, ensuring that the future values are scaled within a particular range. After this normalization, the split allows independent evaluation of unseen data. So we are just splitting the data set in terms of training and testing. So this PQSVZ is the quantum kernels, which transforms this classical data into quantum state. So in the classical world, the classical data is operating on classical system. In quantum, we have to convert the classical data into quantum data, and then we have to execute in the quantum system. So converting this classical data into quantum data is a very important thing. And the term that used to denote this converting this classical data into quantum data is called as future mapping. The future mapping is the process of converting the classical data into quantum data. So this converting these futures can be attained in terms of various, we have future maps like Z future map, ZZ future map, and poly future map. In this work, we have used the Z future map, which given the high accuracy. Z future map is nothing but the rotation of around the Z axis, that is called as Z future map. Whereas if you see in ZZ future map, the rotation will be around ZZ axis. In poly, we'll be having the rotation around XY axis. So the PQ-SVC model is initialized with the defined quantum kernels, and also this PQ-SVC is a stochastic gradient descent method. The regularization is controlled by a parameter. There are two parameters that is set here. That is C. The parameter C is set to 1000, and the number of trainings is set to 100. Here is the architectural diagram of the PQ-SVC model. First data loading, then pre-processing, then define parameters like 7 qubits. Why we have initialized the 7 qubit is that the total number of futures in the data set is 7. So the number of futures should be set as the number of qubits. So 7 futures, so 7 qubits has been set. Then here is the parameters. So defining quantum kernel, we are using Z future map. Repetition is that how much the complexity can be increased. The repetition is a trainable parameter. Reps is equal to 1 is set in this experiment. You can also increase the repetitions, no issues. Then compute and uncompute method. So after that, we'll be evaluating the model. So here is the
Sorry to interrupt, ma'am. Your 9 minutes are over. So kindly wrap yourself.
Okay, sir. So here is the quantum neural network. So quantum neural network, the circuit diagram represents like this. First one is RY. RY is the rotational gates around the y-axis. Then basic entangled layers. Basic entangled layers is used for understanding the more complex relationship in the data of the data set. Finally is the final symbol that like half semicircle with an arrow, that is called as the measurement gate. Measurement gate is very important for converting the classic, that is measuring the output probabilities. So here is the resultant discussion. First figure 3 shows the future values after scaling, and figure 4 shows the objective value function over iterations. So if the x-axis is the iteration, so up to 100 iteration it has been run, and the objective value function has been fluctuated, and finally it achieved an accuracy of 88%. So here is the fig 5 represents the bar chart of the accuracy of two different algorithms. PQSVC achieved 88% and QNN achieved 70%. So here is the table indicates the performance metrics of the models. So you can these are the different class. It's a multi-classification problem. So multiple classes have been taken. So conclusion, these findings highlights the effectiveness of quantum enhanced classifiers by leveraging this quantum future encoding and circuit-based optimization. PQSPC demonstrated superior accuracy and computational efficiency. The result emphasized the transformative potential of quantum computing in precise agriculture, paving the way for more advanced decision making. In crop monitoring management, future work will be based on optimizing the QNN architecture, exploring the hybrid quantum classical models, and expanding the dataset for further validate the robustness of these quantum models. And here are the references. Thank you. Open to queries.
Can you more elaborate the PQSVC model?
Yes, sir.
Can you elaborate more upon the PQSVC model?
Okay, the Pegasus quantum support vector classifier is an extension of this SPC. So in the quantum, we have two things. First one is quantum support vector or classifier, and another one is this Pegasus quantum support vector classifier. First of all, it is a stochasticated gradient descent method, and also it uses quantum kernels. So those quantum kernels will be used for mapping this classical data into quantum high dimensional data. So basically in SVC will be the mapping of this high data into a future space, that is high dimensional space, requires kernel trick, whereas in quantum you don't, the kernel trick is not necessary. Once you use this quantum kernel, the data has been mapped into high dimensional quantum Hilbert space to exploit the potential quantum advantage in future representation. So this quantum kernels plays a major role. So
Thank you.
All right, and just a quick question. What specific quantum algorithm did you find the most effective in predicting crop yields?
So as far as I've experimented, I think this Pegasus quantum support vector classifier possesses high accuracy, sir, when compared to quantum support vector classifier. Why is that? In quantum support vector classifier, it's like only there are steps like a feature mapping. There is no parameterized quantum circuit that is being used in this quantum support vector classifier. Whereas in PQSPC, the quantum parameterized quantum circuit are being used. So it helps to capture the more complex relationship in the data. So it achieves high accuracy.
Yeah, awesome. Thank you.
Thank you, sir. Have a great day.
So up next we have Shengguan Zhao. He is presenting the paper title Integrating Internet of Bodies and Reinforcement Learning to Create Adaptive Architectural Space in VR, a research framework. So are you there?
Yeah, I'm here.
Okay, so you can start your presentation.
Okay, can you see my screen?
Yes, sir, it is visible.
Okay, hi everyone, I'm Shenghuan Zhao. I am an assistant professor from UCSI University, Malaysia. I focus on smart building design and engineering. So when I talk about architecture, I mean the building really existing in the physical world, not that architecture in the field of ICT. My presentation contains 4 sections. First, I would like to introduce some concepts about terminology. Then I will show you the research intention. Then the main part of my conference paper, 4th stage of the research framework. In the end, conclusions will be made. I think many of us here have heard about or clearly know what is the concept of Internet of Things. Internet of Things it has a lot of devices embedded with sensors and connected together to exchange data all over the internet. Internet of Bodies is an extension of Internet of Things. In IOB, Internet of Bodies connects the human body to a network through devices, either worn, digested, or implanted to monitor and collect data. A short video. among research integrating human physiology, Internet of Bodies with VR, brain waves, especially EEG, is the most frequently measured indicator. My lab also has tested EEG measuring with self-assembled sensors. As you know, there have been many commercialized hardware and software to measure EEG. However, using the collected data is not so freely, so we assemble sensors by ourselves. The second concept is reinforcement learning. Its goal is to construct a control strategy that maximizes the performance of an agent. The agent perceives information from a complex environment and process that information. The agent improves its performance and selects behaviors through learning, thereby generating choices for group behaviors. Individual behavior selection and group behavior selection enable the agent to make decisions to choose a certain action, which in turn affects the environment. Let's take a look at an example. On the left part of the slide, it is a case of a robot learning to avoid a fire. It observes, then select action. If it touches the fire, then it will get a penalty. It will get a 50 points detection. Now it learned, okay, do not touch the file. Here is another case about reinforcement learning. Okay. The third concept I wanted to introduce is virtual reality. Virtual reality is a simulated experience that can be similar to completely different from the real world. We have two other similar words, augmented reality and mixed reality. Augmented reality is the real world with virtual elements overlay on it. And mixed reality, the virtual elements have collision with the real world. We have a short video demonstrate differences, also from my own lab. The left girl, she was using virtual reality, and that girl, the right girl, she was using mixed reality. They are totally different. Here are two VR headsets I used before. For the latest VR hardware, we have standalone VR headsets. It means that we do not need a computer anymore. The headset is a small computer itself. With the development of VR hardware, it was integrated with social media platform. Around 2 years ago, the concept of a metaverse was sweeping us around the world. It became a big buzzword and attract a lot of investments. There had been design competitions organized to promote the social awareness on metaverse architecture. However, all the design results turned out to be mediocre. Nothing new come out. The fever of metaverse has been increasingly going down. The main reason is boring. All the metaverse architecture is boring. They are still very boring. So my research intention is to offer more exciting VR experience for users. I'm developing an intelligent VR platform which offers adaptive and tailored VR spaces based on users' real-time physiology and subjective preferences. This user in the VR environment and the architecture space can adaptively change in 1 second for this user, this specific user. Even though two users are communicating with each other in the same thing of metaverse, they still can have respective tailored perceptions of the environment. So here, it is the main part of my conference paper. I listed the framework. It includes 4 spaces. Let's go to the first phase. In the first phase, we set up a database of adjective words. We use web scroll and keywords like architecture, architecture design, and architecture space to fetch liberal contents related to architecture space from websites and social media. And then we use natural language processing to clean and filter those contents. We delete punctuations and other unnecessary information. And then we use NLP package to filter out non-adjective words and those not for describing user feelings. By doing that, we obtain a database including a great number of adjectives describing feelings induced by architecture spaces. With a word-finding algorithm, we can assign a value to each word, identify the frequency of its usage. Meanwhile, we do sentiment analysis of those words and assign a value to each word, identify the degree of positiveness of those feelings. For instance, we define words in the range between 0 to 0.45 are negative, and words in the range between 0.55 to 1 are positive, and the other words are neutral. It's kind of effective computing. And then we set up a parameterization system to describe the virtual reality architecture space. And for example, this rectangular space is a function of A, B, C. There will be two major categories of architectural space prototype. One is a regular space is dominated by rectangles, and the second one, irregular space is dominated by curves. We
Sorry
also
to interrupt, sir. Your 9 minutes are over.
Okay, I'll speed it up. Okay. And the hardware, we use VR headset and physiology measuring system and a multi-angle and the software, and it's the workflow, data workflow. We publish new batch of parameters into the VR environment. Then the users select the words and we measure their physiology status and feedback to the computer end. And we will conduct massive testing and do the data collection. Then we will use reinforcement learning to make the agent to learn in which condition we should publish new space parameters for VR users. Then conclusions. It has a significance for many industries like military and psychology, but it also has negative concerns. People may lose interest in living in the physical reality, and also the data safety we also should consider about. Thank you so much. Any question? Let me know if you have any question.
Sir, do you have any doubt?
Yeah, I have conducted two parts. One is collecting physiology. That system we have built up. On the other side, we have built up our own metaverse platform. But I still haven't integrated them together.
Okay, sir, I'll look into it and let you know.
Okay, thank you.
Yes. So up next we have Wang An Pham. He is presenting the paper title Leveraging RSA Accumulator and Blockchain to Enhance User Profile Based Authentication. Wang, sir, are you here?
Yes, sir. We are here.
Okay, sir. You can start your presentation.
Few second to share.
Dear presenter, are you there?
here.
Yes, sir. He's presenting his screen.
Sorry, I didn't use to the chat yet. So see my screen.
Yes, sir. It is visible.
Thank you. So I will present now. Okay, so hello everyone. My name is Kim Wing, and I'm a master's student in computer science at Ho Chi Minh City University of Technology. And my research focuses on blockchain, and here are our emails. Feel free to contact us if you like. And now I'm going to present my research on leveraging RSA accumulator and blockchain to enhance user profile-based authentication. So the presentation will be divided into 4 parts: the introduction, proposed approach, evaluation, and conclusion. So first is an introduction. So nowadays, as the internet expands rapidly worldwide, authentication has become very important, consuming a lot of research efforts, because it's crucial to know the user behind the screen is your user and not somebody else. So there are a lot of authentication systems, but they can be divided into 3 main categories. The first one is the knowledge-based, like username and password. The second one is ownership-based, like YubiKey or smart cards. And the last one is inherent-based, like fingerprint and facial recognition and the like. All of them have their own advantages and disadvantages. For traditional profile-based authentications, it belongs to the knowledge-based category. It leverages information about users, their attributes, and behaviors to try to authenticate them. So its merit is that it's easy to use and do not require any special hardware or objects, but also has some limitations, such as the user privacy, vulnerable to some attacks, or the data integrity. So in order to mitigate those shortcomings, Yumin Wing decided to integrate blockchain into the profile-based authentication. The new system is called MBPBA and use Merkle tree to minimize storage and enable verification on-chain. But the Merkle tree also has some shortcomings, like the proof grows as the data grows, and it does not verify when the root hash is changed in the dynamic environment. So we proposed our approach using the RSA accumulator instead. The next section is about our proposed approach. And this is our proposed system. It is inspired by the Merkle tree PBA and also has 2 main flows, one for registration and the other for login. Here in the backend, instead of a Merkle tree, we changed it to RSA accumulator. At its core, for registering, users fill out their profiles, hash the answers, and the system updates the hash digest based on the data input. And for the login flow, it uses a hybrid method to authenticate users. The user will first provide their username and password. Then the system will choose a few questions about their profile. And if the answers are correct, then access is granted. And while the user is using the system, the behavior can also be collected to update their profile. This is how the RSA accumulator looks like. It consists of 3 parts. A genesis number represents an empty set, a hash function that has the item into a prime number, and a RSA modulus number. Then the digest will be calculated as a power modulo of the genesis to the product of the hash of the whole dataset, all modulo n. These 5 formulas are related to this accumulator. They are the formulas that are used to update the digest, witness or verify the accumulator, and the 3 above are for the on-chain to update or verify a digest, and the 2 below are for off-chain to update witnesses. Then it's time to construct an item hash. The primary hash will follow the suggestion of Beric. First, we hash the item using the black2b hash function, then pass L0 bits to the right, and then we enter a loop and add odd numbers into it and check if it is a prime number using Miller-Rabin algorithm, and if it is, it will stop, and that number will represent the item. For each type of data, we construct the prime number a little bit differently. For user, we can directly use the public key instead of hashing it because they are unique to each user, and we can also pass a user ID so that on-chain can determine if that item belongs to this user or not with verify. And the auxiliary number is adjusted to make the prime number as the algorithm from the slide before final. The next problem is to calculate the witness. So the RSA number n has a special number Vn. It has the unique property that it can be used to calculate practically any witnesses for any arbitrary input.
Therefore, storing this number can make the data structure very simple, but it introduces a very critical risk of leaking the VN, and with its leaks, the RSA is not safe anymore. So we decided to discard this number at the time of generating N, but the witness must be calculated from almost an entire set. It would be CPU intensive. So a more complex data structure will be required to store part of the computation results to increase the calculation speed. This is the data structure that we suggested using the tree-like structure similar to the compact Spark Merkle tree. And each node has a value. This is the production of its leaves, the max key to find the correct leaf, and we introduce the cage that can be used when they traverse the tree. So when traversing, if one part of the tree is calculated, we can reuse them without recalculating them again. Next part is the evaluation. So this is the evaluation of on-chain actions. Notice that only the verification requires the most resources, but it is still within the allowed threshold of the cardinal chain, so I dare say that it is feasible in this chain. Next is the computational time of witnesses. And as you can see, as the item number increases, finding an item becomes slow, but using cage, the next item can be able to reduce part of the computed witness and make the calculation process faster. And lastly, a little bit theoretic, as comparing in the three security criteria between the two PBA systems using blockchain, when using Merkle tree and our RSA accumulator profile-based authentication, we can see that the two fit all the criteria given, and more of them can be found in the paper. All right, in conclusion, we have presented an alternative method to the Merkle tree for a profile-based authentication system. And theoretically speaking, it offers improved storage efficiency and validation capabilities on-chain, while it also preserves the security attributes similar to that of the existing systems. And lastly, the experiments and evaluations demonstrate that it is feasible to build a system based on the proposed approach. But there are many things that could be improved in this system, and I would like to name a few. The first one could be that we have to find a way to securely generate as a modulus number n, because it would be catastrophic if the number Vn were leaked out. And secondly, I'd like to introduce some batching technique to group many on-chain actions together to reduce the number of on-chain transactions for multiple actions. And lastly, we can research using a hash function that produces large odd number instead of prime number to make the hashing pretty easier. And this is the references we used in the slide. And that concludes our presentation. Thank you all for listening. Any questions so far?
Yeah, hello. I only have one simple question, which basically the application of your study. What real-world scenarios influence your design choices in building this secure profile-based authentication using blockchain? Like, how
Yes,
can how can you relate it to providing solutions that address real-life challenges?
yeah. So the authentication profile-based authentication system is already a system for long ago, but it has some limited, like it can be some security attributes about the data of the user. So some research about has used the blockchain to enhance the security level. I am merely about to use an alternative approach to the core bit.
All right, great. Yeah.
Yeah.
Thank you.
Yeah, thank you. Any other questions?
Thank you, sir. Sir, you can stop your presentation.
Okay.
Okay, thank you. Up next, we have Marwa Mokni. She's presenting the paper title Optimizing Cloud Computing Effective NLP-Based Corrective Approach for Resource Level Management. Ma'am, are you here? Hello, ma'am. Marwa, ma'am, are you here? Okay, I think she's not here. So before moving forward, I would like to call the participants who are absent before. E. Sujata ma'am, are you here? Okay.
Yes, sir.
Rukiye, E. Sujata, are you here, ma'am?
Yes, sir. We are here.
Okay, okay.
Now
So, sir, you can start your presentation.
I can start my presentation. Okay, sir.
Yeah.
Can I share my screen, sir?
Yeah, just a second.
Okay, sir.
Okay, now you can share your presentation.
Okay, sir. Are you able to see my screen, sir?
Yeah, it's visible.
Okay, sir. First of all, good morning, everyone, sir. My name is Sheikh Mufizur Rahman. I'm gonna present this project with my team. First of all, I am gonna present our topic name is blockchain-based Web 3.0 application, revolutionizing healthcare. In this project, we are gonna do this is we explore the intersection of blockchain technology because in today's world the technology is increasing day by day. So we have to evolve with our technology and our system also. So right now the best system for everything decentralized system is Web 3.0, sir. So we are gonna use this Web 3.0 in healthcare systems. We are going to use this Web 3.0 in healthcare systems because of blockchain data storage like in healthcare systems many diseases contain many storage problems like patient information and hospital info, and definitely many storage information we have to store. So further to in this application we are gonna present by using blockchain technology. We are gonna do predict seven different diseases. Actually, the first model has only one disease prediction. So by evolving into Web 3.4 model, we are gonna evolve into seven different types of diseases at one application itself. So this is a change. This is a major change we done in our project by through modification through lot of modification with an web application also. In that web application in that publication in that web application in that web application, patient will be, first of all, an interface will be like this. The patient will be asked like symptoms, approximately 8 symptoms will be asked by the patient, like his body temperature, he has cold, or he has different types of symptoms. So through that symptoms, we can predict what disease he can easily he is having with 97 percentage of success. So this project, the purpose of the project is the purpose of the project title blockchain based Web 3.0 application is to principles to enhance the healthcare sector. The process mainly aims like improving data security. In today's world, data security is very important, and many organizations are working on it to improve data security, because blockchain is the only one technology who have decentralized. No one is going to control this, just an computer is going to control this. So in healthcare systems the data is very important. Like changing data will not be encouraged, and it will be very major problem if will be data will be changing frequently. So the decentralized technology in healthcare systems is the new era, and it will be started through Web 3.0 technologies. So it improves data secure storage and sharing the patient data, reducing the risk of breaches in between the data. And the second purpose of the project is enhance the interpretability, facilitate seams data exchange between different healthcare systems, like enabling the privacy and collaboration among healthcare providers. And the third thing is empower patients, allow patients their justification of empowered patient is the greater control over this medical record enabling there or share information with providers and other terms, because the data will be vary from one organization, and it will be evolved through the people, authorized people, like it won't be shared like public. It will be like privacy within the organization and with the branches of the organization. The methodology of this webchain project is data collection, data processing, CNN model, computer numerical natural model development, web development. In this methodology we use it these things, and modified our project deployment and maintenance. In this project, we have used machine learning in Python, and also web development. The purpose of this review was to view the trends in composition studies within the past 40 years and how commentary on study writing has changed and still changing. It is very clear from the research review that evaluated commentary is very impressed. Like in today's technology, machine learning is the major thing in artificial intelligence. Through that we can train a model like sir, the machine what's the difference between machine and a human brain is in that machine we can train one human will be trying to teach machine with one machine can be able to get information from 40 people and think as fast as human and more than human. So this is why machine learning is used to predict the future and the greater results and efficiency with results, because more than human. It is very clear form of research reviewed the evaluating commentary is very impressed and widely practiced. Along with this, we also clear that the field of composition studies just regards to the types of commentary that most benefit composition student and society at large. Brain tumor classification used in this project blockchain. We have 7 diseases to predict. Brain tumor classification using convolutional neural network. Technology has potential to significantly improve the diagnosis of brain tumors, leading to improved patients' outcomes. Because brain tumors is a major disease in today's world, facing because of the younger people also facing through brain tumors and cancers like this. So by knowing in early age, we can small stage stage one itself. If you know about our disease, then it will be very helpful to cure the disease and make precautions and guidance from the doctors, so that in our web application we are providing this brain tumor classification using convolutional neural network. Technology has potential by automating medical images analysis and classification that improves provide medical profession with a reliable of efficient tool for tumor diagnosis. One minute, sir. I have a picture. I have a picture to present. I'm gonna share my screen. This is a picture where we are teaching machine to how to showcase this, sir. Like we are gonna present 7 diseases. I have said cancer with symptoms from patient itself. Through these symptoms, we are gonna do this, sir.
What is the data set size for your experimental process?
Sir, random forest, the data sets we are gonna use this CNN computer neural network, and also random forest application. We use it for teaching. We use it for training the machine learning model.
Okay, thank you.
Okay, sir. Okay, sir. Can I go?
Okay,
Oh,
sorry.
okay, sir. Thank you. Thank you very much. Okay, sir. Thank you.
Okay. So I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being part of this international conference. I hope this session was informative enough. We, on the behalf of whole team, thank you for the support during this 10th version and all the previous 9 versions of the conference. We will be happy to have you in the 11th version in 2026. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already forwarded for the stringent. The publication will be live within 6 months. Kindly cooperate with the team of ICICT 2025. I thank our session chair, Professor John Helen Jaspers Ortega, for chairing this session. A token of appreciation to the chair on behalf of Team ICICT 2025 and Global Knowledge Research Foundation and partners.
Yeah,
I
thank you.
also thank
Thanks, sir.
our second chair for the session, Dr. Navneet Sharma, for chairing this session. A token of appreciation to chair us on behalf of Team ICICT 2025 and Global Knowledge Research Foundation and partners. Sir, do you have any closing remarks?
Yeah. Thank you so much. Thank you, all the participants. All the best and best wishes for your future endeavors. All the presenters have presented their presentations in a very good manner. All the best from my side. And thank you, the GR Foundation team, to be present this session as a session chair. Thank you so much.
Okay, sir. Thank you. Thank you for your valuable presence. I kindly request all to switch on their cameras for a quick snapshot for a virtual conference.
So if it's possible, you can please turn on your camera so we can capture this good memories of this virtual conference. Okay. Thank you everyone. Thank you for your valuable presence. And thank you all the authors for their wonderful presentations. Thank you.